Alright, so we have the review for tomorrow's quiz, so this is it. So, you remember probability in games, so on this one right here we have two gates. One's open 20%, the other one's open 30%, and then right here it's open, both of them are open 10% of the time. I'm not going to give you this point stuff, I'm going to give you the actual percentage inside the test, the quiz. So, let's see, so this is the probability that both of them are open. And you got to realize 10% is going to come from the 20 and the 30. So when we go ahead and draw this right here, we're going to go ahead and draw a Venn diagram. This is going to be real simple to do. So you have your run-of-the-mill square. You have your two circles. This is gate 1, gate 2. This is open 20% of the time. This one's open 30% of the time. Both of them being open will definitely be 10. Since 10 comes right here, that means 10% comes from this 20. So you should take the 20, you subtract 10 from it, so that's going to be 10. Get rid of that. Then the same thing for the 30 right here. 10% comes from the 30, so that's going to be 20. Get rid of that. And then you add all three numbers together. 10, 20. That's going to be 40. Subtract that from 100. That gives you 60. So 60 goes out here. So the kind of questions that I'm going to have right here. What's the probability that gate 1, only gate 1 be open? Well, that's 10%. Only gate 2 will be open would be 20%. Probability that both gates will be open will be 10%. Probability neither one of the gates will be open will be 60. And finally, what is the probability that only gate 1 or only gate 2 are open? Well, you just take 10, 20, add them together, that's a total of 30. And so that's the end of that one. Another type of question that we're going to get here is the main components. Is this one, probability of driving and risk. So you have to read the passage to be able to get the total number of people, which is 500, 230 of whom are male, and then all that good fun stuff, and we'll go ahead and apply that to this. Now here's the key, here's the tricky thing about this. I'm going to ask you to make a tree diagram, not the Venn diagram, just the tree diagram. So here goes the tree diagram. It's a real fast process. We have to take a little bit of work. Alright, now let's see, we have this stuff. So we have males and females. So let's see, we have 230 males out of 500. That's equal to 0.46. Then we have 270 females out of 500. You can either do the math or subtract that from 100. 100 minus 46, which of course is 54. Alright, so that's for males and females. Then we have the types of vehicles. So we have cars, no vehicle, and then we finally have motorcycles. So we have 230 males, 150 of them have a car. So we just take 150 divided by 230. That's going to be 0.65. Then we have the other one, 23 divided by 230. That gives us 0.10. Then finally add these two together and subtract that from 100. That gives you 0.75. Then we have finally accident, no accident. So let's see, we have out of the 150 cars, 40 of them got into accidents. So it's 0.26, and then of course, actually 0.27. Sorry. So that's 73%. Then let me see, that's okay. So motorcycles now. So of the motorcycles, if we look at that, 6 out of 23 got into accidents. So that's going to be 26%. And finally we got this one right here, which is going to be 0.74. Same thing right over here. Okay, now we have let's see. We have 270 females, 225 of them have a car. So 225 divided by 270, I think that was 83, so it's 0.83. Same thing for the other. This is going to be 10 out of 270. Well, that's going to be 10 divided by 270. That's a very low number, so that's like 0.04. Finally, add these two together, that gives, and subtract that from 100, that's 0.13. We have accidents, no accidents. So out of the 225 cars, 15 females got into an accident, so that's 0.07. So subtract that from 100, that's going to be 0.93. And finally, we have accidents, no accidents. Okay, make sure everything's come through. Yes. We have 4 out of 10 motorcycles got into an accident which were driven by females, so 0.40. And then of course the final one, this is going to be 0.60. Alright, so things are going to come up. Probability that a male will get into an accident. So we're just doing this for males. So you find the probability of the car, first off. So it's 0.46 times 0.65 times 0.27. And that will give us 0.08. So that's 8%. Also, we do that for the motorcycles. So that's 0.46 times 0.10 times 0.26. That gives us 0.01 or 1%. So all that together is 9%. So 9% that a male will get into an accident. We also do the same thing with the females. So probability that a female will get into an accident. Well, let's see. That's going to be, first we do the one for the accidents for females, 0.54 times 0.83 times 0.07. I don't remember what this answer is off the top of my head. That's been a while. 0.54 times 0.83 times 0.07. That's going to be 0.03 or 3%. And then you also have that for the other one. Let's see. So that's for motorcycles. So 0.54 times 0.04 times 0.40. So it comes out to be pretty close to 1%. So it's equal to 0.01, which is equal to 1%. And so you add those together, so we say 4% probability. And that's about it. Good luck on the quiz. Get that work into me.